Deriving the left side gives us, derive sine first, that becomes cosine, leave the inside the same, and then we multiply that by the derivative of what's inside, which is the product rule. So we derive the first term, or the first part of that product first, so the derivative of x is 1 times y squared, plus x times the derivative of y squared, well that's 2y times dy dx. That's the derivative of the left side. And that's going to equal the derivative of square root of y is 1 over 2 root y times the derivative of what's inside of that, which is dy dx. I'll squeeze them in there. So now what we got to do is, anytime you do this implicit differentiation and you've got a lot of multiplication, all these parentheses going on here, you want to simplify it first before you try to solve for dy dx. So I'm going to distribute this cosine xy squared into these parentheses here that's being multiplied by, and what we're going to get is, we'll write a little bit smaller, y squared times cosine xy squared plus, this is 2 times y times x, so that's 2xy, times cosine y, or cosine xy squared, and that's dy dx is still tacked on the end of there, so times dy, so that's x 2y, made that 2xy, times the cosine xy squared, I'm multiplying in there, and then dy dx at the end, and that equals 1 over 2 root y dy dx. Now what I'm going to do is get all the terms of dy dx onto the left side, everything without a dy dx on the right side, and then factor out that dy dx. So what you should see after you do all that magic, is you should have dy dx times 2xy cosine xy squared minus 1 over 2 root y is equal to negative y squared cosine xy squared. So a little bit nasty, I will agree with you on that one. We're almost done though. Dy dx is on the left side, it's being multiplied by this large quantity, so we're just going to divide by that quantity that we do not want. So dy dx is going to be negative y squared cosine xy squared all over all this nonsense here. We're dividing by this, so that's 2xy cosine xy squared minus 1 over 2 root y. And maybe you're seeing this right now and you're thinking, oh god, I don't want to deal with this, but we've got to. You do not leave complex fractions in your answer, and that's what we got going on here. So even though it's hideous, it's ugly, we don't like it, we're crying right now maybe, I don't know, we cannot leave this 1 over 2 root y in the denominator here. So what we do, this is one big fraction, is we multiply by the denominator that we don't want, so we can get rid of that complex fraction. And it ends up with dy dx is, multiplying in this 2 root y will give me negative 2 y squared times root y, which is y to the 1/2, is y to the 5/2 cosine xy squared all over 2 root y times this nasty looking thing will become 4x y to the 3/2 cosine xy squared minus 1. Yep, 2 times 2 is 4, x just hangs out, y times y to the 1/2 is y to the 3/2, and cosine xy squared just hanging out. And then 2 root y times 1 over 2 root y is 1.